Hello everyone. So today we'll do some fun stuff. As you can see, this time there is no variable that we're changing. We will get a shell. We have int main void, and just to make sure that you people don't get used to like 8-byte multiples, I have a buffer of 10 characters, a scanf, and something that prints. Puts us something like that there. But what's the fun part about it? Unrestricted input reading, scanf %s. So %s will keep on taking input while you're giving it input. It will just continue. So what are we going to do now? We are going to do a very simple thing, and that is to overwrite means return address. So we want to do that with the return address of bin. And this is something I want to explain in detail. So exec is something that replaces your current process with another process. And as you can probably figure it out, execv is the C function equivalent of that command. So exec is a command. I'm not going to run that because okay, I'll just run it. Now as soon as I close it, both of them will close because the process will close. Yeah. So anyways, execv takes two arguments. The first one is the path to the binary that we want to execute, and the second one is the arguments to the binary that we are giving. So you all remember how I said argc argv for main, right? So it's similar over here. There is an array, argc will be 1, and array of argc will be null, which is a 0, and array of 0 will be the name of the executable itself. So since we are executing /bin/sh, we need to give it this. So the first argument is bin/sh, second argument is the array. So I hope this is clear. At the very least, this should be clear. Long story short, this is something that is executing the shell for us, and we want to call it from main somehow by overflowing this buffer, obviously. So now compilation, obviously, a couple of changes. First of all, I added this flag no PIE. PIE is position independent executables. We do not want it to be position independent for very specific reasons. We will come to those reasons later on. Second one is exec stack. Once again, we don't need the stack to be executable. I just set it. F no stack protector. We kind of need this. I'll tell you once canaries show up. For canaries, you need to do a bit of a hassle to read canaries. So yeah, overwrite funcs.c and compile it to overwrite. So I hope flags are clear. NoPy is something that we will come to. It's something that I cannot explain in a video. In any case, compilation done. So how do you now mind you, I did not put debug flags because like you obviously won't be having them. So how do you find out the function? So every function is corresponded to with a label in the underlying assembly. So this finds all the functions for you. Info functions, it will find all the labels, the symbols as we put it. So ignore everything with an underscore. They are not relevant at the moment. Ignore everything with an @PLT. They are also not relevant at the moment. When we have this and we have main, so first disassemble main and see what's going on in main's assembly. Yep. So standard stuff. RDI takes for scanf. Just remember it. Like you don't need to remember it, but like you can clearly see this string is close to the hard coded area, like the text section or the code section of the binary is hard coded, right? And this is close to that. So like this is at an offset from that. So this is probably some, I don't know, some hard coded string. So we can check this. Percent %s. Perfect. So there's an overflow. There's an overflow definitely happening. The second thing is this RVP minus 0xa. So this is a local variable of the stack. Obviously, as I said, RVP minus 0x something is a stack variable. So good. RSI is taking the local value and RDI is taking the format string. Perfect. Now we call scanf and then we do something with puts, which is not relevant. So scanf. So scanf is vulnerable in main. We can overflow main. Now let's see if we have any other functions of our use. Now the only other function is win. After puts, there is another another hard coded string that we are loading. So once again, let's check the value for this one. Bin slash switch. Wow. So we are getting a shell, a string for the shell at least. So like, let's see how that happens. Uh, we move this value into RB minus 0x10, which is okay. First of all, we load its address, not the entire string. Move it into RAX, the address, we load the address, and then we move that address into RVP minus 0x10, and then we move null into RVP minus 0x8. That can only mean one thing. There are two consecutive elements. The first one points to a string that has that is bin slash sh, and the second one is null. Perfect conditions for exec b. As I said, like you obviously don't know, but this is something that you need to know. So as I said, this this RBP minus 0x10 and RBP minus 0x8 is perfect for our use case. So another thing that you probably might have observed is arrays grow upwards, just like strings, because like well, string is also an array. So yeah, regardless, anyways, we load them and then we call execute. Perfect. So we are executing what bin slash sh, but we are not calling win anywhere in main, as you can see here. So how do we call win? Obviously, we call it our way. Now to show you, I'll run it once so that you understand how the stack frame will look like when you overflow it. Now the first that we loaded, so in RSI we loaded the buffer address, which is this 346. This is 348, so -2, so these two, and so we have, how much do we have to overflow? We'll start filling from here, 2 bytes, 8 bytes, 8 bytes of RBP, and then finally the return address. So to show you the segments, I'll fill in A, then B, then C for all three right now, and then we'll restart and fill the actual address. So N9, A, 8, 9, 10. This should fill the buffer. This should fill RBP. This should fill return address. As you now, I'll do the hex dump so that. So from RSP, we started filling from here 2 bytes of A, another 8 bytes of A, 8 bytes of B, and 8 bytes of C. This should be clear now. So instead of the 8 bytes of C, we have to fill the return address. This was just to show you the segments in which we were filling it. So let's start again. GDB. So I'll straight away run, and like this is syntax for inputting. So like just remember there's nothing more to it. This will happen inside GDB. Like this syntax is inside GDB. Left arrow space, left arrow brackets, and the command inside the brackets. Like, import this dot out dot buffer dot write b a star 10 of a plus 8 of b. This should fill up. Oh wait, we didn't see the address for win, right? I forgot noting the address for win. So let's this as win. This is the start address for win. Uh, Now that I have copied it, yeah, perfect. So let's start. So this is just the once again this is just the syntax of how you send input in GDB. Oh yeah, now 461140, that's done. And yeah, that is our input. We have not set breakpoints, so let's see if it works. Yep, it did work. So this string was present there in win for starters, and it changed into slash bash. There's a reason why it changed. It did that on my system for a reason, but like long story short, it tried to execute the shell. I'll come to this as well. So like yeah, don't worry. Cool. So this is what happened. Now we need to execute it outside. So object, I forgot the command. So minus p will give you the disassembly for the executable section, the code section. There's a so for code section it will be the same both inside and outside GDB. For stack it won't be. We'll come to why later. That will be a session. So as we can see, main win. Let's scroll above just to see something plt in it. We'll come to all of it Monday. Maybe not in it, but like I hope you can come to in it. Depends on your cooperation. So yeah, the same address. So we have to execute it inside outside of GDB. So I think so. Luckily, okay, I'll do it in bash actually. Ten plus b star 8 plus backslash x 4 6 slash x 11 backslash x 40 plus 600 star 5, and we save this to a file. Oh my bad. So b has to come. because like all of them are bytes. This was a Python error. Anyways, now we have bytes. So some garbage characters towards the end. That's not the point. The point is we have the string stored in this file, so we just pipe it, which you would know if you did bandit. So we pipe it to overwrite. Oh wait, what? I executed bash, but like as you can see, it clearly did not hold. Like there should be two exits, right? One for what I called and one for what the process gave me, but there was only one. So the reason is when we execute bash this way, it just exits on not seeing any input. So a simple way to keep it open is you might have some of you might observe this with netcat as well. So a simple way to keep it open is cat file1 file2. Now if you give just a minus, it means standard input. So it will keep reading from standard input, which we can give at our mercy. So it will keep the thing open. Ls, we got a shell. So let's say we remove the input file we gave. Gone. So who am I? Innocent 0. UID. Okay, maybe not. I don't know. Uh, in any case, you see that we got a user. We got a shell also. So ls slash bin. See, let's cat readme dot. Okay, it was empty. Okay. Yep. So as you can see, we have a shell now. So yep, it did work. So the difference was we had to add this minus, the dash, which specifies read from stdin. So what it does is spits out our input and then uh, keeps it open for us to give things from stdin, and now we can control the out of it as well. Yeah. So I hope this was clear. Once again, I'll show you the code. Uh, One thing I mentioned was that the stack, that the code addresses will be the same both inside and outside GDB. That makes sense, right? Hmm. But what won't be the same? The stack addresses. Why is that? You have to figure out. The answer is pretty obvious actually. Like the way GDB works. Just think about it. What could be? What could it be? Another thing was GDB tried to execute. It did not try it. Executed slash user slash bin slash bash. There was a reason for it. It's a symlink. On my system, it's a symlink. Yeah. I'll, yeah. See, it symlinks to bash on my system. So that's just how it works. There's nothing you can do about it. On your system, if there's a bin slash sh, it will execute bin slash sh. So don't worry about it. It won't try to execute bash. But yeah, this is how well a simple buffer overflow attack looks like. Believe it or not, the most major problem of current software, I guess. Why so much software is written in C? So much. And well, programmers are stupid for most part. If they weren't, we wouldn't be existing as a club. So yeah. Bye bye. Hope you understood. If any doubts, obviously the group is there, quads are there. Not my DM, please. I am already being flooded with a lot of stuff. So like not my DM.